Lesson 7-6, Parametric Equations. Parametric equations are equations that have separate equations for x and y, where x and y are functions of a third variable called a parameter, such as this one. Notice x is a function of t, and so is y. So in this case, t is the parameter. Well, we can graph this by making a table. So here's my table. What I did is I picked a bunch of values for t, plugged them in to find the x and the y. And then these are the points that you graph. You graph x, y. So we had negative 5, 5, negative 4, 2, negative 3, 1, negative 2, 2, negative 1, 5. Notice, though, we don't just draw this parabola. We have arrows on it. The arrows show the direction the graph goes as t, as the parameter, increases. All right, let's graph this one. In this case, theta is the parameter. But we do it the same way. We graph it by making a table. So I make a table where I go from 0 to 2 pi for my theta. And then we find the x and y. So you plug in a 0 for both of them. You get 2 for x, 0 for y. I happen to go by pi over 4. You get a better graph the smaller the increment is between t or theta, between your parameter, the better your graph will be. If we graph these, we'd have 2, 0, square root of 2 over 2, 0, 2, negative square root of 2 over 2, because we're graphing these points of negative 2, 0, negative square root of 2, negative square root of 2, 0, negative 2, and there. And so you see it makes a nice circle, and you put the arrows showing the direction the graph goes as theta, as the parameter increases. Sometimes you'll want to eliminate the parameter, which means that you are going to make it just a regular function with x and y. So you do that as just substitution. So you solve one equation for the parameter and substitute it into the other equation, and the parameters will be gone. For example, well, I could take this first equation and solve it for t. So multiply both sides by the square root of t. Divide by x, and square both sides. Then I can take this second equation and replace t with the 1 over x squared, which simplifies. See, if I square it, that would be 1 over x to the 4th, which will give you 2 over x to the 4th. If you multiply by 2. Let's try eliminating the parameter in this one. Well, this one's going to be more difficult to solve it for theta, because then we'd have like the inverse cosine of x over 2. And then we'd do sine of that. That'd be weird. So we do, though, have a trig identity that says sine squared plus cosine squared equals 1. So if I take this first one and solve it for cosine, which would be x over 2, and the second one and solve it for sine, which would be y over 2, I could substitute those. So I'll have y squared over 4 and x squared over 4 equals 1. This looks like an ellipse, but the a and b are the same. It's really a circle. If we multiply both sides by 4 and rearrange, we get that. So it's a circle with a radius of 2. To go the other direction, to come up with parametric equations for some equation, you choose something convenient for t. For example, this would be convenient for t. So we can say t equals 4x, and then solve it for x. So t divided by 4 would be x. And then, of course, so let's write this out. X is t over 4, and y is, well, all that was t minus 3. Here are functions, parametric equations for the different conic sections.